Now folks, this is K.W.O.N again, and the Captret. So perhaps you've seen a video from RB Pointless 2 claiming over Unity or free energy. So I decided to bring some light into this mistake or this misunderstanding of electrical devices. So okay, the setup, my meter is hooked up right now to this little capacitor here. Well, you can take a smaller one or this one here, and I've hooked up the case of the 1000 microfarad 16 volt capacitor here to this black wire going to my clamp here, and hooked up the voltmeter across the capacitor. Well, perhaps you know supercaps store a little charge or will recover a little charge, so I can short it out and it will recover a little energy here. Well, that's normal. That's it has nothing to do with over Unity or free energy, but that's not the point right now. So I have a little LED here and old 9 volt battery, so this battery is now to 8 volts or something like this. Okay, let's put you here and let me show you the scenario we have. Alright, first I should charge the capacitor here, and I'm going to do it this way, and you will see now we have 8.2 volts going down, because in these meters you have variable resistors, and these variable resistors consumes some energy of the capacitor. Somewhere around 6 volts it will stabilize, I think, because the resistance is then so high that it needs a long time to discharge. Okay, now the scenario of the video was the case here connected to this wire. I'm going to connect it to the negative end of the LED, and now I'm going to put the positive end to the positive side of the capacitor, and you will see it will light up a little bit. I hope you can see it, and you will also see the voltage is going down, but slowly. So I don't know if you see some light anymore here, but when I connect it there will be a little bit of light. So I should do this same thing again, but I should turn off the light. So let me charge it again, put it back to the meter and turn off the light. I'll be back in a second. Let me find my things again here. Okay, now I try to find the case and the side here. Well, it's real dark. I can't see anything. Okay, now you see a little green light here, and that is the discharge from the capacitor. You see it? Okay. So I'm going to turn the light on again. So put it up again here, but can't see any light. I can see a little bit of light here by touching the positive end. But you can see the voltage will drop down. When I get it away, you will see the voltage will also drop down, but very slow. As I said, due to the normal discharge, okay, and the variable resistors in the multimeter. But you see, it really slowly goes down. When I hook it up, you can see the discharge is faster. You see it? Well, at a point around 1 volt, you can't discharge it this way with the LED anymore. Of course, you need some volts to get across the anode and cathode plates. But okay, let's discharge it again. Well, okay, now we have got some light out here. What I can show you now is we can now put the LED the normal way, and that is did you see the light and the fast discharge? Well, let's do it again. Charging. And discharging it through this LED. Did you see that? Well, so what's the point of RB pointless 2? I don't know, but the point is here. The case is also made of aluminum, and it is connected to the negative side of the capacitor. So you can take the positive end and also charge the cap over the case of the capacitor, and you see it's charged. Well, it will not charge to its full range because there's a I would say imaginary resistance between the normal negative side and the housing or the case of the resistor, the capacitor, and that causes a limitation in the current flow, and so you see the discharge will go this way, just slow, because it's limited. Now I'm gonna measure the resistance between the negative side and the aluminum housing or case of the capacitor. So now I'm gonna hook up the meter. It's on the 20 mega ohm scale. Well, it says nothing. I'm going to turn it on the 200 mega ohm scale. We'll build it up to 2.5, 2.6 mega ohm. So to check the resistance, you have to put a little voltage across, so you can also charge the cap by reading it with the resistance, but you don't get an accurate reading. So 2.6 mega ohm is not the real resistance here, because there's a little flow of energy through the cap, and the cap will build up a charge. So when I turn it off or disconnect this one here again and connect it again, wait a sec, so 2.5, 2.6 mega ohm, 2.7 mega ohm. Let's disconnect it again and short it out so there's no charge left, and hook it up again, and we'll slowly build up the resistance. So I said there's a imaginary resistance between the case and the negative side of the capacitor. That is why you can get a little blinking here often and often and often again, but if you keep the LED here, it will discharge, and yeah, when you put the LED the right way, and discharge the cap directly through the LED, you get the normal light up. But now you see the LED is direct across the cap, but it stays at 1.68 volts, 1.67, just slowly going down, or not really, because as I said, it's not enough voltage to cross through anode and cathode of the LED. So yeah, due to the resistance between the capacitor case here and the positive side, you have the limitation of current flowing, and that will waste energy, because you have to go over the resistance, and it will limit the output of the capacitor. Nothing else, nothing special, and not even free energy. It's just a waste of energy. Alright, I hope this brings some light into the question of the cap trap. Thanks for watching.